Hey guys, how's everybody doing? I hope everybody's doing good. You're having a good day. Um, you've been enjoying yourself. Again, make sure that you're taking care of yourself with all this COVID-19 going on. Make sure you're washing your hands. Okay, don't touch your face. Try to stay as much as you can in home. All right. Um, Hand sanitizer, all that kind of stuff. Hygiene. Hope you guys are taking care. Okay. Today, this video, we're gonna be focusing on reviewing lesson 6. Okay, and working and introducing with lesson 7, which we're transitioning into coordinate planes. All right. This is our focus for today. Um, Again, guys, if you have any questions, please let me know. Shoot me a message through Class Dojo or email. All right. I'll try to answer as soon as possible. Make sure you guys are also doing your practices, which is in the page that we've been working. All right. And I just want to state that Eureka Math, which is with New York Engage, I do not own the rights. Okay. We do use this math with my 6th grade students at our school, Academy del Sol. And this is for my 6th graders. So let's dig in, you guys. All right. So the focus for this lesson, okay, it's lesson 6, which is area in the real world. So we're getting situations that in the real world we actually use. So I'm gonna read this. It says, below is a drawing of a wall is to be covered with either wallpaper or paint. The wall is 8 feet high and 16 feet wide. Okay, so it's 8 feet high and 16 feet wide. Okay. The mirror, window, and fireplace are not to be painted or prepared. So I'm just gonna put a little X here myself to just let me know that they won't be painted. The only thing that will be painted is all of this space in white, which is the wall. Okay. The window measures 18 inches. All right. We gotta be careful with that one. We gotta convert those inches into feet. Okay, so I showed you here an example. 6 inches is half foot, 12 inches is 1 foot, 18 inches is 1.5 foot. So it's 1.5 feet wide, okay, 18 inches wide and 14 feet high, okay. That's our window. And then the next one is the fireplace is 5 feet wide, okay. So this is our fireplace. It's 5 feet wide, 3 feet high. So 5 feet wide and 3 feet high. While the mirror above the fireplace is 4 feet wide. So it's 4 feet wide and 2 feet high. Okay, this is not drawn. It's not drawn to scale, like we've gone over before. It's just there for the practice. All right. So now we're going to focus on these questions. How many square feet of the wallpaper are needed to cover the wall? All right. So I have here the work, all right, for this assignment, just for letter A. This right here is all my work for letter A. If you want to pause the video at any moment, pause it. Okay. We're in letter A. There's very reduced amount of space here, but I will walk you through this. All right. So we're focusing on A. So we have to find the areas. Okay. So looking at this side by side. Okay. I found the area of the window. So which is a 14 by 14 feet times 1.5, which I did here. And I got 21 feet squared. Okay. And then I found the area of the mirror, which is 4 times 2, which is 8 feet squared. And then I did the fireplace, which is 5 times 3. And I got 15 feet square. I added those 3 items. And I have a little sketch right here created myself. 15 plus 8, okay, plus 21 gave me 44 feet squared. Okay, all together. Kind of put a little arrow right there, showing that these three areas add up to this amount right here. Okay, 44 feet squared. And then my next step was to find the area of the wall, which is this one right here on the outside, which is 16 times 8. And I did 16 times 8, which equals 128 feet squared. There's my actual work. Okay. Same thing here for the decimals. That's how I got 21 feet. Okay. There's my actual decimal. Okay. So I got 128 feet squared, which is the area of the wall. Okay. And then the last step that I did, I subtracted the area from the wall, which is 100, which is this one right here, 128 minus the area of the three items, which is the window, the mirror, and the fireplace, which is 44. And I got 84 feet squared. All right. So the answer for A is 84 feet squared. Okay. Again, if you have any questions, please let me know. Okay. Send me a message or through Kaz Dojo or an email with any information about this, and I can help you, right? Or pause this video. Now I'm going to focus on B. The wallpaper solid in rolls are sold, in rolls that are 18 inches wide and 33 feet long. Rolls are solid colored. Wallpapers will be used so the patterns do not have to match up. So I have a look at number B1. This is a Roman number 1. What is the area 1 roll paper? Okay, so they give us the dimensions. It's 33 feet long and 18 inches wide. Again, same thing here as in the problem on the top. 18 inches equals 1.5 foot. So I created a little sketch here of how the roll paper looks, which is 33 feet long and 18 inches wide, which in other words, 18 inches is 1.5 feet. Told me to find the area. So I multiplied 33 times 1.5. Here's my work. Again, if you need to pause this video to look at it, pause it. Okay. So the area of the roll paper, which is 33 by 18 inches or 1.5 feet, is 49.5 feet squared, or 49.5 feet squared. All right. That's B1. And then B2, how many rolls would need to be, how many rolls would be needed to cover the wall? Okay. How many rolls would be needed to cover the wall? So what I did is I divided the 84 feet squared from number 1, which is the area that was supposed to be painted or covered with paper. And I divided it with the area that we came out is the area of the amount of paper. So I divided that. Here's my actual work. Okay. I moved the decimal on both of them one spot. I ended up getting, okay, at the end, I get 1.6 rolls, which is right here. Now at the store, they won't sell you 0.6 of a roll. They won't get a roll and almost cut it a little bit more than half, right? You have to buy either 1 roll or 2 rolls. So you only need 1.6 rolls, but you need to buy 2 of them, all right? So it says right there, how many rolls do you need to cover the wall? You need 2 rolls, all right? Which is right here. And here's my work for B2. Again, if you need to pause the video, pause it, okay? I'm gonna jump to letter C now. And it says this week the rolled papers are on sale for $11.99 per roll. Find the cost covering the wall per paper. So what I did is they're selling each roll for $11.99. How many rolls do I need? 2. So I multiplied $11.99 times 2 rolls, and I got $23.98. All right. So that's for letter C. Okay. If you want to look at that work, pause it. If you need to rewind the video, do it. And then the last one, a gallon of special texture paint covers 200 square feet and it's on sale for $22.99 per gallon. The wall needs to be painted twice. The wall needs to cover 2 coats. So what they're doing, imagine this is the wall, okay? And I paint it, okay? I paint this entire paper, which represents the wall. I'm gonna let it sit for a few minutes, hours, wait for it to dry. I'm gonna come up again and put another layer of paint. So it has 2 layers of paint, okay? Find the cost of using paint to cover the wall, okay? So what I did here is I multiplied again the 84 feet squared, which is the amount of wall that needs to be painted. But since it's going to be painted twice because it's 2 layers of paint, I multiplied 84 times 2. Again, 84 means the 84 feet squared times the 2 layers. I got 168 feet squared. And that equals 1 gallon, which means 1 gallon covers up to 200 feet squared. So you're still gonna have extra paint left over, even though you paint the wall twice. So imagine I paint this wall. I'm gonna paint it once, let it dry, paint it again. Okay, that's 168 feet squared. Okay, I still have some paint left over for the future or whatever, but how much does each gallon cost? $22.99, right? So it says right there, find the cost of using paint to cover the wall. Again, they only sell you by the gallon. They won't sell you by an ounce or anything. They sell paint by the gallon. So each gallon costs $22.99. All right, there's my work for number 1. I'm gonna jump to number 2. A classroom has a length of 30 feet and a width of 20 feet. The flooring is to be replaced by tiles. If each tile has a length of 36 inches, we need to convert those into feet, and a width of 24 inches, how many tiles are needed to cover the classroom? Okay, so the first thing that I gotta know is that 12 inches are in 1 foot. So if I do 36 inches by 12, 36 inches equals 3 feet. And if I do 24 inches by 12 inches, that's 2 feet. So 36 is equivalent to 36 inches is the same as 3 feet. 24 inches is the same as 2 feet. So that helps us work with the problem. So it's letting us know that the classroom has a length of 30 feet and the width of 20. And I did an example here. The length of 30 feet and the length of 20. And what I did to find the area of the classroom, I multiplied 30 times 20, which is here. And I got 600 square feet. So that's the area of the classroom. Okay. And then I found the area of each tile. The tile is, the length is 3 feet, which is right here, or 36 inches. And the width is 2 feet. So I multiplied 3 times 2 feet and I got 6 feet squared. And then I divided that. I divided the 600 feet squared with the 6 feet squared. Why did I divide the 600 and the 6? Because it's trying to find out how many tiles we need. And we're going to need 100 tiles, all right? If you divide 600 with 6, you're going to get 100 tiles, all right? So that's the answer for number 2. Okay, the answer for number 2 is 100 tiles. This is basically the work right here. Okay, and I even provided here 12 inches equals 1 foot, 24 inches equals 2 feet, 36 inches equals 3. Okay, so that's the work for number 2. If you want to pause it, okay, rewind it, look at it. Okay, take your time. Moving on to number 3, it's a challenge. And now it's saying assume that the tiles from problem 2 aren't available. So they're saying that the 3 feet tiles by 2 feet tiles, they don't have them at the store. They're sold out, so you got to buy another one. Okay, another design is available, but the tiles are a square. And again, squares, all sides are equal from a square. So it says that one side of the square is 18 inches. So if one side of a square is 18 inches, that means that the other 3 sides are also 18 inches. And 18 inches in feet is 1.5 feet. All right. So if we look at this, I drew the square of the tile. Okay. I still kept the 600 square feet. That's the size of the classroom. But now what I did is I multiplied 1.5 times 1.5, which is right here. This is my work. And I ended up getting 2.25. And then divided the 600 feet by the 222.25 feet to find out how many tiles are going to fit in my classroom. Okay. I divided, ended up getting a repeating number. Okay. So I got 267, okay, tiles. All right. 267 tiles. All right. That's the amount of tiles that we'll be needing for number 3. All right. So now I did 1.5. Again, where did I get the 1.5? It's saying that they don't have on number 2 that they have the 3x2 tiles. Okay. These are tiles, by the way. It's tile. Okay. These are not 3x2. These are actually, it's 6 inches. It's 6 inches by 48 inches. So it's half a foot by 4 feet. Okay. So now in the store they're selling this one, which their small tiles are probably like this. They're like from here to like right here, and then it's just 1 foot each side. Okay, 1.5 feet. And this is the actual work. All right, 267 tiles. If you put this down as well, I'll count that correct. or some of you, I saw that you gave me this. I'll do that as well. All right, because you can actually cut tile. All right, you can actually cut tile, but you're gonna need to buy at least 267 to cut a little piece. All right, so 267 tiles. That's number 3. Now let's jump to number 4. Which is this one right here. Alrighty. So on number 4, it's saying a rectangular flower bed measures 10 by 6, which is this one this white one in the middle. That's why it's shown by this tally mark. So from this point, and let me use my pen to point that out. From here to here, that's 10 meters. Same thing. From here to here, that's 10 meters. And vertically from here to here, that's 6 meters. And vertically from here to here, that's 6 meters. So it's 10 by 6. The white is 10 by 6. It has a path of 2 meters wide around it. So that means that everything here that's in gray is 2 meters. This is also 2 meters. Okay. Everything here is also 2 meters wide. And everything here is also 2 meters wide. Okay. Find the area of the path. So we're trying to find the area of what's here in gray. Okay. So we're trying to find the area of what's in gray. So what you need to find is, let's do the outside. Okay. If you notice that from here to here is 10 meters, but I'm telling you that this spot that's missing is 2 meters. This is going to be 2 meters up to here. And this is also going to be 2 meters, which up to here. So if you add them, 2 plus 10 is 12. And 12 plus 2 is 14. So 14 times. And then you look at this one as well. This line right here, if it stops right here, this is an extra 2 meters. And right here, it's an extra 2 meters. So 6 plus 2 is 8. And 8 plus 2 is 10. So the area of the total shape is 140 meters squared. Okay, you want to find, this is the total area. You want to find what's the flower bed. The flower bed they told us, which is this right here. I'm gonna outline it, which is the one in white. The flower bed is the rectangle that's in white. So we're trying to find the area of this white spot. So it's a 6 by 10. This is 6 long and this is 10. They tell you here. So flower bed 6 by 10, which is 60 meters squared. Okay, and they want to find out what's the area of the path. Okay, the path is this in gray. Okay, we found the area of what's on the outside. We found the area of how many squares fit inside of everything. We found the area of the flower bed, which is white. Now we want to find out the area of the path. So what you need to do is do 140 meters squared minus 80. I'm sorry, minus 60. Here's my 60. And I'm going to put them in bubbles, the ones I'm working with. And that gives you 80 meters squared. All right. So if you want to look at those steps, look at those. All right. Pause the video. If you need to rewind it. All right. I recommend you guys, every time just rewind. It's good to rewind and look at them and ask any questions if you have any questions. All right. And I'm jumping to number 5. I told you guys to focus on A. Okay. And just focus on A. A diagram of Tracy's deck is shown below, shaded in blue, with here it looks gray. He wants to cover the missing portion of his deck with soil in order to grow the garden hose. So he wants to know how much this is the area to find out how much soil he needs. Find the area of the missing portion of the deck, write the expression to evaluate it. Okay. So if we look at this, all right, this entire bottom line is 8 meters. All right. This is 8 meters. And if you take away 1, 8 minus 1 is 7. and this one is also 1. They look the same. 7 minus 1 is, so the size from here to here is 6 meters. If you think about it, this is 6. If you add this one, that's 7. And if you add this one, is 8, which makes the entire line. Okay, and then they give you a clue with this one. If from here to here is 2, this side is also going to be 2, right? So all you had to do was multiply 6 meters times 2 meters, and that equals 12 meters squared, all right? And this whole thing was your actual answer, all right? This is the most simple one that we had in our homework, all right? That's pretty much it. These ones, I told you guys to ignore them, all right? It's asking the same thing in different forms. I think that we've practiced enough, all right? And you guys are also showing me how to do these with the practices as well, okay? So I'm gonna do the last one. It says the entire large rectangle below has an area of 3.5 feet square. So the area of this big rectangle is 3.5 feet squared. If the dimensions of the white rectangle are shown below, write and solve the equation for the area A and the shaded region, all right? So it's telling us to find the area of this rectangle, which finding the area of a rectangle, okay, here's a work, I don't have much space. We use base times height, okay? We use base times height. So I'm gonna multiply 3/4 times 3/8, which I did right there. 3/4 times 3/8, and you multiply going across. So 3 times 3 is 9, and 4 times 8 is 32. So that's the area, and I put it inside there. Now that explains what's inside there. Okay, so the area of this is 9 over 32. And I saw most of you got this, but you forgot one more step. Okay, so 3 times 3 is 9, and 4 times 8 is 32. That's where I'm getting it, base times height. Okay, but the other step is I have to subtract the area from the big rectangle, which is 3.5 feet, and subtract it from 932. Okay, so what did I do with this mixed number, which is 3.5? I turned it into an improper fraction. 2 times 3 is 6, plus 1 is 7, 7 over 2. They both have to have, if you look at the denominators, they have to have a common denominator, which is 32. So if I do 16 times 2, that will be 32, which is here. But I got to do the same thing with the, if you notice, I have to multiply both of them with the same number. 16 times 7 is 112. Now I can subtract 112 minus 9 is 103. And these ones stay the same. Okay, that's how it works in subtraction. And then I divided 103 divided by 32, and I got 3 7 over 32, which is, that's the answer for that. So if you want to look at these steps, pause the video, rewind it. Okay, this is lesson 6. Okay, again, if you have any questions, let me know. That was lesson 6. You guys have been doing a great job. I'm so proud of you guys. Keep on doing that. All right, make sure we do that. So I'm gonna jump to our lesson for the day, which is lesson 7. Okay, and this one's pretty cool because we're going to what we call the coordinate planes. These are pretty cool. All right, so we look at so we're measuring for distance. We want to know how far is one point away from the other. That's what we want to know, distance. So how far is Valencia's home to Academy del Sol? Or how far is Circle K from Quick Trip? Or how far away is Academy del Sol to the hospital? That's distance from point A to point B, or point B to point C. Okay, and you're able to see that nowadays. I'm gonna put this right here really quick, and I want to show you a real life example of when we use coordinate planes. We don't really pay attention to it. Okay. Okay. So this right here is an example. All right. This right here is an example of of a coordinate plane. We don't look at it, but we're looking at the distance, right? This is one point and this is another. And if you look at it, it kind of does what we do. We count, you know how we count in X, how many to the left, how many to the right, going up or down. And it lets you know the miles. To me, it lets me know the miles. So every certain distance counts probably as a mile. So I just want to show you guys how they use coordinate planes in real life. All right. That's why math is so beautiful. And we say, why do we need it? You know, if math, we use it on a daily basis. It's just that we really don't think about it. Okay. So it says determine the lengths. So the lengths of the given line segments. So remember that line segments are these, all right? So basically, you know, point A, point B, and you would represent it doing it like this, and you draw an actual segment on top of it, okay? This is saying this, and this is saying that, all right? So this is read line segment AB, all right? This is how you read it, line segment AB, from point A to point B, okay? From this is kind of like me. Valencia's home, drives to Academy del Sol to work. Then you guys leave home, and then Valencia has to drive back home, right? So, and if you look at here, it says line segments. Here's a line segment. We have to put the point, the distance, all right? And for the proof, we're not really gonna put anything for proof there for right now until you know, see me do it and explain what the proof means, okay? But I'm gonna focus on this one right here, okay? And I'm gonna begin with line segment AB, okay? So I gotta focus on where's AB. So I'm gonna label this, and remember, just to remind you guys, this axis right here is the y-axis, and this is the x-axis, all right? And I like to label it to help you guys. This is our positive y's, and anything below this line right here, this is the origin. Anything below the origin, this is the y negatives, okay? On the right, this is the origin. The origin is where it begins. On the right side of the origin are the x positives. And the left side of the origin, these are the x negatives, all right? And then usually, and not usually, we always, when we write coordinate points, it's always the x first, and then the next one is the y's, all right? Same thing for this one, because it's a point, it's always the x, and then it's the y. So I'm gonna look at the first one. It says line segment AB. So I look at here, and this is segment AB, all right? It's from here, A, all the way to B. So that's what we're focusing on. But before we focus what's the distance, we gotta know what's the point of A. So if I look at here, there's two ways I can do it. I can count up and then count to the right, or do the opposite, count left and then drop down, okay? So I'm gonna do the first one, okay? I'm gonna begin here, okay? And I'm gonna say, I'm gonna begin here, and I'm gonna count to the left. 1, 2, okay? But it's on the left side of the, this is like a number line. So these are negative x's, so it's 1, 2. So I move 2 spaces, so it's -2. And then I'm gonna count up. 1, 2, 3, 4, 5, 6, 7, 8. And it's 8, and it's on the y's, and what y's is on the positive, so it's negative. So we found the point, it's -2x, positive y. The other way you can do it is do it this way. You can start from here and go 1, 2. Well, it's on the negative side of the x's, okay? So it's -x, okay? So it's -2, which I wrote down there, and now let's count it. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 spaces. So the A is located on what? It's on the positive y's. Okay. So we have that. And now let's count the B's. So I begin at the origin and count 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's landing on the positive x's. So it's +9 x. And now let's count the y's. 1, 2, 3, 4, 5, 6, 7, 8. So it's +8y. Okay. So now we know the points for A, which is -2, 8, and we know the point for B, which is 9 and 8. Okay. now we're gonna state the distance. There's two ways you can do this. Manually, you can count by hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. The distance is 11. Or the other method you can do is by working with the proof. All right. And we're going to focus. If you notice, the y stayed the same. They're both 8s. The ones that are different are the x's. All right. So we're going to work and use absolute value. Okay. The absolute value of 9 plus the absolute value of negative 2. And remember the rule that I've always told you, boys and girls, it doesn't matter if a positive or a negative number are inside the absolute value, they will always come out being positive. So this is, it's like saying 9 plus 2, okay, which is 11. All right, there's your proof. Okay, I got the numbers from here, my positive 9 and negative 2. Why did I get the 9 and a negative 2? Because if you look, the 8s stayed the same, so they're not moving. The ones that are changing are the x's. All right. So let's focus on the next one, BC. So now we're going from here to C. All right. So I'm going to find we already found the point B. All right. We already did that on the first one. And we found out that B is 9, 8. We already found out that B is 9, 8. Okay. And I can prove it to you again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Positive 9 next. I wrote it right there. And it should be 8y. 1, 2, 3, 4, 5, 6, 7, 8. There we go. 9x, 8y. And then let's look at C. Where is C located at? Here we go. Let's focus on the x's. Let's begin here. 1, 2, 3, 4, 5, 6, 7, 8, 9. It stops right there. So it's positive 9x. And how many y's? 1, 2. It's going up towards a positive y, so it's positive 2y. All right. And we can count the distance from each other. Okay. I'm going to show one method. 1, 2, 3, 4, 5, 6. That's the distance from B to C. Or now if you notice, this one's the opposite. The x's stayed the same. Okay. The x's stayed the same, but the y's changed. So this is a form of proof we could use. Okay. And there's different forms of proof you can use. You can use 8 minus 2. In this case, I'm going to do this. Now this one, okay, if you notice that the minus symbol is outside the absolute value, so this one saying 8 minus 2, that equals 6. All right. Be careful. Look at the difference between these two. This one converts into a positive 2. This one, since the minus is outside, it's like saying 8 minus 2. All right. Look at the next one, which is CD. Now we're going to do from C to D. Okay. We know that the point C, we found it right now, which was here, was this one, 9, 2. Now we got to find point D. So I'm going to count, I'm going to begin with the x's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And it's on the positive side. So it's positive 9x. And now we're going to count down. And it's going to be negative because it's going towards the negative y's. 1, 2, 3, 4, 5. So it's negative 5. Okay. 9, negative 5. And then I could count the distance between C and D if I want to. 1, 2, 3, 4, 5, 6, 7. And if I look at here, again, the 9s didn't change, but the ones that change are these ones. Okay. And I'm going to show a form of proof. Absolute value of 2 plus the absolute value of negative 5. And this is like saying 2 plus 5, which is 7. All right. I'm going to jump to the next one. Now it wants us to find B. Okay. It wants us to find B. all the way to D. All right. So I looked at the point B, and we already have it at the top, which is this one right here. This is point B. It's 9, 8. The one that we and point D, we also found it, and it's 9 and -5. Okay, and what I'm gonna do here, and I didn't do the beginning, guys, and this was one of my mistakes, and I'm human. It's better for me if I label the point so that I don't have to go back and struggle with that. So point A is -2, 8. Point B is 9, 8. Okay, this is more helpful. Okay, point C is 9, 2. Okay, and point D is 9, -5. And I guess this makes it a little bit, I don't guess, it makes it way easier. Okay, so now I'm going to count the distance from point B. Okay, from point B to point D. Okay, from point B to point D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's the distance. Okay, and if you notice, the 9 stay the same. The numbers that change are the y's. So I'm going to show proof. I'm going to get the absolute value of 8 plus the absolute value of -5, which these both come out positive. It's saying 8 plus 5, which is 13. Awesome. Now we're going to find D to E. So we already know that the point D is 9, -5. Since we labeled it, that's going to save us a lot of time. The only one we need to find right now is point E. So I'm going to begin with x's. 1, 2, which is on the x negative side, which is here. 1, 2, so it's -2x. And then I'm going to count down. 1, 2, 3. Okay, I'm going to do it again. 1, 2, 3, 4, 5. And it's on the negative y's, so it's -5y. Okay, and I can count the distance between D and E. Okay, I can count the distance. So this one is -2, -5, this point E. So I'm going to count from D to E, from D to E. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Now, if you notice, this one's the y's are -5s. They stay the same. So the ones that we're going to work with are the 9 and the -2. So the absolute value of 9 plus the absolute value of -2. 9 plus 2 is 11. All right. Let's focus now on point segment EF, which is from here to here. I'm going to find F. Okay. E we already know is -2. -5. And then F, let's see. 1, 2, which is -x. So it's -2. And then 1, 2, which is on the y's. So it's -2y. All right. And now we can count the distance from F to E. 1, 2, 3. Okay. The distance is 3. Okay. We notice that the x are the same, -2, -2. The ones that are different are the y's, -5 and -2. So we're going to show proof, okay? And I'm going to say the absolute value of -5 minus the absolute value of -2. Now I want to explain this one. This -2 does turn into a positive, but we have that minus symbol still in the middle. So it's like saying 5 minus 2 equals 3. And there's your proof, okay? There's your proof. The next one it wants us to find, and this was point F was -2, -2. Forgot to label that. Okay. Now it wants us to find from point F, which is right here, point F to point G. From point F to point G. Well, point F is -2, -2. And let's find point G. Begin here. 1, 2. Which is on the x's negative side, so it's -2. And then let's go up. 1, 2, 3, 4, 5, 6. So it's on the positive y, so it's positive 6y. Okay, and let's count the distance from F to G. 1, 2, 3, 4, 5, 6, 7, 8. So 8 is the distance. If you notice, the x's are the same, -2, -2. The ones that change are the y's, -2, +6. So we're going to show the proof. The absolute value of -2 plus the absolute value of 6, which is saying 2 plus 6 equals 8, and there's your 8s. All right, so G is -2, 6. All right, and now we're going to find E from E to G. From E, which E is -2, 5. -2, -5, I'm sorry. I forgot to label that, -5. -2, -5. And G is -2. That's the point G, -2, +6. All right, so we're going to count from E to G. From E to G. 1, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. The x's stay the same. The ones that change are the y's. So I'm going to do the absolute value of -5 plus the absolute value of 6, which is saying 5 plus 6 is 11. All right. Now it wants us to focus from G to A. The point of G is -2, +6. And then point A is -2, 8. Okay, and let's count the distance between G to A. 1, 2. That was easy. The x's stay the same. The ones that change are the y's. All right, we got to be careful with this one because we want it to show ended up at +2. So I'm going to do with this particular problem, I'm going to put the 8 first, absolute value of 8 minus the absolute value of 6. Okay, that equals to 2. Now here's the thing, boys. Why didn't I do 6 minus 8? Because if I do 6 minus 8, that's going to end up being a -2. All right, so you're just setting it up to where it's going to come out exactly as in the distance. That's why this is called proof. All right, be very careful with that. And then we're going to do from point F, which is -2, -2, point F, -2, -2, and point A, -2, 8. So I'm going to count from point F to point A. From F to A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The ones that change, x's stay the same. The ones that change are the -2 and 8, which are the y's. And this one actually stays the same. Okay? Because if you think about it, this won't hurt because we're not subtracting. The absolute value of -2 and the absolute value of 8 equals 10. And then one more, and then we're done. From E to A, so from E, which is -2, -5, to A, which is -2, -8. And we're going to count the distance from E to A. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay? And if you notice, the x's stay the same. The ones that change are the y's. So I'm going to do the absolute value of -5 plus the absolute value of +8, which is saying 5 plus 8 is 13. And there you go. You have that. If you want to pause it, look at it over. I'm confident that you guys are going to feel really good about this one. You're going to do great. All right. That's what we're doing. We need to find the points first. Let's label them. It makes it easier. You save a lot of time. Okay. We find the distance and then we show proof. All right. We show proof. I'm going to jump to the back here. Okay. We're like 33% done with this, but it's going to go quicker. Okay. So here are the line segments. It wants us to do the same thing. The line segments, put the points, the distance, and the proof. So we're going to begin with point B, I. So we're going to do B to I. So first I gotta label the point B. So these are positive y's, these are positive x's, these are negative y's, and these are negative x's. All right. So let's see. This is my point of origin right here where the lines intersect. And I go 1, 2. Okay, it's on the negative sides. So it's negative 2x. And then I'm going to go up 1, 2, 3. So it's on the positive y's. So point BI, okay, is at this point. Okay, so so we have that, we have point B, and now if we look at I is on the x-axis, so it's pretty neat. We won't have any y's, so we go 1, 2. That's where I is located at. So it's negative 2, and it doesn't go up or down. It stays on the x-axis, so the y is 0. All right, and now let's count the distance from I to B. 1, 2, 3. We look at the x's, negative 2, they didn't change. If you look at the y's, they're different, 3 and 0. So I'm going to do absolute value. The absolute value of 3 plus the absolute value of 0. So 3 plus 0 equals 3. All right. So I'm going to label these points so that I forget. Point B is negative 2, 3. And I is negative 2, 0. All right, so point I is negative 2, 0, B. All right, so now I'm going to focus on point BH. Well, I already know the point B, which is negative 2, 3. But I do got to find point H, which is this one. So let me go ahead. It's 1, 2, which lands on the x's on the negative side. So it's negative 2x. Now I'm going to count down. 1, 2, 3, 4. And it's on the negative y's. So it's negative 4y. All right, and I'm going to count from point, and I'm going to write it right here so that I don't forget. It's negative 2, negative 4. That's the y, h. Now I'm going to count them from point B to H. Here we go. Point B to H. 1, 2, 3, 4, 5, 6, 7. And I'm going to show the proof using the absolute value. If you notice, the x's don't change. The ones that do change are the y's. That's what we're working with. The absolute value of 3 plus the absolute value of negative 4, which is saying 3 plus 4 equals 7. All right. Now we're focusing on point B. Again, we already know that point B is negative 2, negative 3. It's up here. I'm sorry, positive 3. I don't know why I put a negative 3. I'm sorry. Negative 2, positive 3. And we got to find point E, which is right here on the bottom. Okay. So let's see, begin of origin, 1, 2. It's on the x negative side. So it's negative 2. And now we're going to count down. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's on the negative y's. So it's negative 9. Let's count the distance from point B to E. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, the x's don't change. What does change are the y's. So I'm going to do the absolute value of 3 plus the absolute value of negative 9. 3 plus 9 equals 12, and there's your 12s. All right, so point E is negative 2, negative 9. Okay, so now we're going to find point G and H. Okay, let's see. Point G, we haven't figured that one out yet. So let's begin to the point of origin. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's on the negative x's. So it's negative 9. And then we're going to count down. 1, 2, 3, 4, which is on the negative y's. So it's negative 4y. And then we already figured out point H, which is right here. This one we said is negative 4. Negative 9, negative 4. And we already have this one, which is negative 2, negative 4. That's point H. Okay, and now we're going to count from point G to H. From G to H. 1, 2, 3, 4, 5, 6, 7. Boom. So now we notice the x's are the ones that change, right? So we gotta show that 7. Absolute value of -9. And I'm gonna do minus, because look at this. If I read it, this is saying 9 minus 2. And 9 minus 2 equals 7, right? If you need help on those, let me know. Point H to C. Okay, we already know what point H is, which is -2, -4. Well, we need to find this point C, which is right here. So I'm going to begin a point of origin, and I'm going to count. 1, 2, 3, 4, 5, 6, 7, 8. So it's positive 8x. And now I'm going to count down. 1, 2, 3, 4. Which is -4 because it's on the negative y's. All right. And now I need to count the distance between H and C, and let me label C, which is 8, -4, from H to C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if you notice, the ones that stay the same here are the y's, the ones that change are the x's. So I'm going to do the absolute value of -2 plus the absolute value of 8. It's like saying 2 plus 8 equals 10. All right. Now let's find GC. We know that the point G is -9, -4, and the point C is 8, -4. Okay, so now we need to count from G to C. Begin at G. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's a lot of spaces. And here, if you notice, the y stayed the same. The ones that we need to show proof are with the x's, which is the absolute value of -9 plus the absolute value of 8, which is saying 9 plus 8, 17. Nice. Now let's look at point C to D. We know C is 8, -4. We haven't found D yet, so let's do that. Okay. So I know that it's in the 8s, okay, because it's landing here where the C is, but I'm going to show proof again. 1, 2, 3, 4, 5, 6, 7, 8. That's where it's landing. So it's +8. And let's see how many y's it goes down. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's -9. All right. And now I'm going to count the distance between C and D. And I'm not going to forget to label this. +8, -9. So we go ahead. 1, 2, 3, 4, 5. The distance is 5. Okay. So if you look at this one, the x's stayed the same. Now this one is going to be tricky. Okay. This is one of the ones that we flip. Because in this one, if I put the absolute value of -4, okay, I'm going to write on a piece of paper right here. Because if I do this, that's why you're going to have to be very careful. Okay. Well, it's actually going to work as well. This one won't work because it's saying that. So it's going to equal 13. So that won't work. If I do -4 minus -9, okay, this one's saying 4 minus 9, and that's -5. So you got to be careful with that. So this is one of those that we got to flip. So I'm going to put the -9 first. Okay. Minus -4. So this one's saying 9 minus 4, which is 5. This is the trickiest one. All right. And I'm going to FG. We need to find F. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's in the negative x's, so it's -9. And then let's count down. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. And it's in the negative y, so it's -9, -9. And we know that point G is right here, -9, -4. And now I'm going to count from F to G. 1, 2, 3, 4, 5. So the distance is 5. Okay. This one is kind of neat. We don't have to change anything. We're going to do the absolute value of -9. Okay. Minus, okay, the absolute value of -4. It's saying 9 minus 4, which is 5. Okay. And then let's find point G to A. So I know that point G is -9, -4. But we got to find point A. That's the last point I think we have to find. Oh, I forgot to label point F. -9. Sorry about that. So let's find point A. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's on the negative axis. So it's -9. And how many does it go up, which is going to be positive x? 1. It's point A. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So it's positive 8, right? And let's count the distance between G and A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the distance is 12. We notice that the -9s don't change here, but the y's do change. So I can do the absolute value of -4 plus the absolute value of 8, which is 4 plus 8 equals 12, right? And the last one, let me label point A before I forget, -9, 8 to F. So the point A is -9 to 8. And point F, where are you at? -9, -9. So we're going to count from almost from the very bottom to the top, or top to down, 8 to F. Here you go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Ugh. Okay. And we notice that the x's don't change, but the y's do. So I'm going to do the absolute value of 8 plus the absolute value of -9, which is 17. And there you have it. Again, if you want to pause it, rewind it, okay, do it in sections, take breaks, all right? That is that. If you have any questions, let me know. Okay, we're almost done with this. And then it's saying, for each problem below, write the coordinates of 2 points that are 5 units apart, which is kind of like this. What's the distance? How many units are apart? Okay, with the segments, any points that are having, okay. So showing something that it's vertical, one solution that can be is -2x, 1y, okay, and +2, +6. If I have something like, if I do a coordinate, okay, and you guys can use your own numbers if you want on the homework, you're gonna get a problem. This one kind of looks like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so this is +2, +1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And this one is +2, 2, 6, which is kind of like that. So these are the points connected, and it's making a vertical line. This is a vertical line, and it's 5 units apart, right? And here's the actual proof. Okay. All right. I want to show you that one. This one, it wants to intersect the y-axis. So I'm going to create one, and I'm just creating one at the top of my head. Okay. I don't have a graph in front of me, but it wants us to intersect the y-axis. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That's y, x. So this one's -3, -4. And then this one is 3 and 1. So if I can connect it, and here's the intersection right there, and I'm gonna zoom it as close as possible. Okay, see if it's able to. Okay, there's the intersection going right there. When something intersects, it means it crosses. All right, it crosses. So it's crossing the x-axis. All right, and then the segment intersects the y. So now it wants us to cross the y. So an example that I'm just gonna give you guys. Okay. So if I do a graph right here, I'll do 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 4, positive 1. Okay, so this one is -4, positive 3, and this one is 1, positive 3. So this one, if you notice, it intersects the y-axis. I mean, it crosses right here on the y-axis. All right, and then the segment is vertical and lies above the x-axis. Okay, so there's a lot of solutions, and I'm just giving you an example here. Okay, so if I draw this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the y's, and these are the x's. If I look at the first one, -3, and then +5, and this one's -3, +10. Okay. And it's saying this is vertical, so the line is vertical. That means it's like this, horizontal. This is horizontal. This is vertical. All right, so it's vertical and it lies above the x-axis, so it's above this line. All right, that's the focus on that. I'm gonna show you the homework. Okay, the homework. They're gonna give you these points. Determine whether the segments joins is horizontal, vertical, or neither. So what I would recommend you guys is it's kind of create like your own graph, like I did myself. You kind of create like 3 little graphs on another piece of paper, and plot, you know, point X, for example, plot point X, which is kind of like 3 and 5, which is kind of like right here, and then plot point Y, which is kind of like right there. Okay, it would look something like that. Okay, obviously I'm missing the tally marks, I'm doing it quick. What kind of line does that look? That right there, that's a horizontal, so you would write down horizontal here. If the line makes this, this is vertical, and this is horizontal. Okay, and there's one that says neither. If it doesn't look going from up down, which is vertical, or if it's going left to right, if it's going diagonal, or it's something else, then you're gonna write down neither. All right. This one, you're gonna do what we basically did here. Okay. Again, I would create little graphs. Okay, and plot them out. Okay. Let me check here. Oh, never mind. Never mind. I don't want to confuse you. So they already gave you the points. What it's asking you guys to do is use the absolute value. Okay. So you guys, if you notice here, the 5s don't change. Okay. The 5s don't change. What you're going to have to do is find the distances. Okay. Find the distance, how far away they are from each other. Okay. If it helps you to plot points, that's cool. There's different spots where you can go online and graph stuff for free. You can go to Google. And give me a second. And you can actually go, like, you can Google, and there's different ones that you can use. All right, I put graph coordinates online. I clicked on the first one, And you can actually, you get this actually page for free. So you can type in, for example, -3, 5. So you can actually plot the first point and let them know -3, -5. And I click label, and look, it did it for me, which is kind of cool. And then the next one is 7, 5. So I go in and let me zoom in. I put 7, 5, and then I click label, and then boom, look at, you actually have the actual points, okay? And you can actually count, all right? You can actually count. I actually wrote this one down, the first one. It's not -5, it's +5. I'm seeing it right here. There we go. So I'm getting the points here, -3. So now I can count the spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And actually this one is a little bit, you can use that, but this one, if you notice, it's by halves. All right. It's by halves, so be careful with that one. Every 2 spaces is 1, so 1 is right here. So there's different pages you can use online, you guys. You can go to Graph Individual, and you can actually put the points here, and it'll graph it for you. All right. So go if you need to, or you can make your own graph and find the distance. Okay. So what you need to do is basically do this. All right. Find the distance, and then show the proof. This one, you're doing the same thing as the lesson, okay? And then again, this one, same thing as the lesson. All right, and then you can come up with something like this, and you can actually get them from here, all right? You can actually get them from here, okay? So if you have any questions, let me know, you guys. This is the actual lesson 7, all right? Again, don't be afraid to ask. The more you ask, the more I can do to help you. But I think you guys are going to be good with this lesson. All right. I hope you guys enjoy your day. Have a good one.